Okay, when I first approached Mr. Abbey and asked him whether we could invite 200 of my closest high school friends into Baker for a day, one of the first persons that George said we needed to be sure was involved was Chris Stott. And he's right. Chris is an amazing guy. You'll get to meet him here in just a moment. He comes from a place called the Isle of Man, which prior to meeting Chris, I'd never heard of. But I'm going to let him tell you a little bit about it. Chris is the chairman and CEO and founder of Mansat, Inc. And it's an amazingly intelligent, insightful business that he started. Many, if not most, of the major satellite providers on the planet now are headquartered at the Isle of Man, which most of them had heard of before. Chris is also the honorary ambassador from the Isle of Man. You know, it's good to be king, and Chris occupies both of those slots. He's an entrepreneurial businessman, and he's an official representative of his government and doing good things in space. Chris is very active in what's called the International Space University, and I commend ISU to all of you. Any of you who decide after debating this year that you want a career in space, you need to be sure. You know, it's tough duty. You have to go over to France and live for a year. But it's really the way to prepare yourself for a career in space. Chris and Nicole are getting ready to move from Houston to Florida today, so we were really honored that both of them agreed to postpone moving day for a day to spend the afternoon with us. And I'm going to stop talking and ask my friend Chris Stott to come up and just, he'll show you why he was first on the list.
Wow. Thank you, Charlie. It's very kind. And thank you for the Houston Urban Debate League for having me speak here today, and my wife, Nicole, and all of us. And thank you, George, and the Baker Institute. And thank you to the prior speakers. I'm humbled to be up here. Thank you. Well, today, what Charlie asked me to talk about was very briefly what happens outside of America in space. What else is the rest of the world doing in space? Despite my funny accent, I'm actually an American as well, but I have spent pretty much all my life before becoming an American living and working in the space community in Europe, in Asia, and around the world. And so what I'm going to try and do is paint that picture for you, give you a specific example of a space country, about what they're doing in space, and then talk to you about why we do these things in space. And hopefully, we'll get to it. Which button do I press? The middle one? Right hand. See, I'm a left-handed person. There we go. See, space technology always works so well. Nope. There we go. Thank you. So make mistakes and learn from them. So when you're talking about space and when you're talking about commercial space, you've got to think about the entire economy. Now, the global space economy is worth round about $264 billion a year. That's how much is spent by government agencies and how much is earned by commercial companies. Give you an example to compare that to. Walk down the street, go to the Galleria, stop anybody and say, have you heard of Angelina Jolie or Brad Pitt or Hollywood? Of course they have. Hollywood in 2009, even with Avatar, grossed $10.2 billion. Space is a huge business, and it is a global business. And there will be copies of this presentation for you, so you can keep these afterwards too. Oh, please work. Great. And what do we do in space? As you heard from some of the other speakers, space is ubiquitous. In fact, the global and commercial space industry has made space such an integral part of our everyday life that we don't even see it there. Actually, it's a bit of a problem for us. We're not a very good proponent of our own industry. Everything from satellite television, weather. Ask any farmer why space is important, and they will tell you for hours. The weather forecasts, using remote sensing to check crops, their health, are they being watered properly? Go to a commodities trader in Chicago and ask them about the soybean crop or the cocoa bean crop in Central America, and they'll be using space. Communications. For the first time in human history, every single human on the planet can be talked to. We can talk with each other, we can talk with one voice, we can debate things with each other. No one was ever able to do this. Ironically, someone with my accent might still have been British. Had the people in the 13 colonies been able to pick up the phone, a satellite phone, and talk to the guys in London and sort out their differences. Communication is a massive tool, and that is something we take for granted. And with GPS, we talked about that. It's everything from arriving at your destination for ships and aircraft, all the way through to farmers getting their product and produce to market at the right time, all the way through to actually building things. It's called just-in-time production. Massive economies of scale through the use of GPS. And remote sensing, Google Earth. How many of you guys have used Google Earth? Yeah, me too. It's pretty cool. And Google Earth is the nth degree on what they call the commercialization of spy satellites. It's really very cool stuff. So this year, and this is taken from the Space Foundation, you can look this up. You always give good sources as a debater. I was a debater myself growing up. So global space economy in 2010 was $276.52 billion, give or take a penny. Now, if you look at that picture, what you're seeing is that the US government space budget was around about $64.63 billion. NASA, 18 to 19 billion of that. You have NOAA, the NRO, you have the various alphabet agencies and the Department of Defense. Commercial spending, infrastructure and support industries, around about 87 billion. Commercial space products and services, that's the satellite communications industry, over $100 billion. And commercial space transportation, getting it up into space, about $0.01 billion. I was very fortunate, as with some of the others, actually I followed in their footsteps. I worked at a company called McDonnell Douglas, which is no longer there, now become part of Boeing, launching rockets and selling those rockets to people with satellites. I never would have had my job if these gentlemen hadn't done their job. And I'm hoping in the future you guys will have a job if I do my job properly. But look at that nice little 8% up in the top left corner, the purple piece. Non-US government space budgets, $22.49 billion. And as you'll see, this is not just the developed nations spending on space. One of the huge questions you're always going to find is, if we have poor people, if people are starving, oh my gosh, if people are homeless, why are we spending money on space? Well, I'm going to answer that for you, or try to. Well, I'm going to give you the answer that others give. So 70 nations have space agencies or organizations, and I'm not talking military, this is civil. 36 nations have space objects registered at the United Nations. It comes out of the Secretary General's office, these outer space treaties, treaties that bind even the United States and their activities in space. And you have these international organizations out there too. The European, lots of acronyms. We love acronyms in space. ESA, the European Space Agency. That's 19 different countries coming together to form a space agency. We think of NASA. NASA's really 50 states coming together to form a space agency. EUMETSAT, all the countries in Europe get together and have their own weather satellites, very similar to NOAA here. And then you have something completely commercial, totally new, and quite revolutionary. The Space Data Association. I'll fly the flag, formed where I was born on the Isle of Man, a fantastic country, entirely dedicated to space, very pro-space government, a government that takes a look at space and says, you know, the best thing about space is space commerce. How can we make that happen? Our version of a NASA is our commercial space industry. And we were incredibly proud about 18 months ago when something called the Space Data Association came and created itself on the Isle of Man. I know, wonderful name. But have a look at it, because it's the first time when commercial satellite operators, global satellite operators, such as Intelsat, came together and decided that they would form an international not-for-profit body that would, in essence, perform an orbital traffic management function. A function not performed by the world's governments. Government doesn't always have to be in the equation. And what you're seeing here is, for the first time, the global space industry getting together to form a self-regulating agency. Commerce can be incredibly good in space. As Mr. Daniels, our previous speaker, was saying, space debris is a huge issue. One of those interesting things is that commercial space, when you're putting a $100 or $200 or $300 million satellite into an orbital position, you want it to be incredibly clean and environmentally pure. You don't want anything to upset your investment. And what you'll find is, in space, commerce sometimes leads the way, especially in terms of environmental applications of space. Now, I know it's the afternoon, you've had lunch, you've had a lot of speakers, so I'm kind of pushing my way through this, knowing that you'll have a copy. But please, as classic debaters, don't take anything I say for granted. Go back, look at this, learn from it, challenge everything in this presentation. I've written it in a way that you can look everything up and challenge everything. So, the United Nations and space, again, very international. You might be astounded to know that space was actually ceded to the United Nations in 1947. They were trying to think of something to give the UN to do that everyone could agree that the UN should do. You know, human rights, refugees, space. Now, the outer space, the Committee on the Peaceful Uses of Outer Space, is the most subscribed, the most attended of all committees at the UN. The United Nations Committee on Human Resources and Human Rights only has 28 members. Space has 70. They have an Office of Outer Space Affairs. They have subcommittees that talk about space law and space regulations and space science. But in essence, it's all of the countries in the world coming together and talking with each other, using space as an excuse. One of the great things to come out of the International Space Station program was the international relations, governments talking to governments at the end of the Cold War and through that very unstable period. The greatest thing to come out of the space station so far is the fact that we actually have 19 to 20 odd countries or more working together to build things in space. It's astounding. Now, we all grew up in a time when we thought, you know, being quite honest, I never thought I'd be standing here in the year 2011 talking to you. That was like science fiction to me growing up. I grew up in the 70s and the 80s, in the UK with a 3-minute warning. 3 minutes and the missiles hit, that was the end of the world. I thought I'd be lying dead in a ditch covered in radiation burns, having taken a couple of shots at some Russians. I had no idea I'd be talking to you today and have the privilege of working in the space industry. And a lot of that is today through the international relations that were established throughout the space program, on the Apollo-Soyuz program, all the way through to Shuttle Mir, and all the way through to the International Space Station program. Never underestimate the benefit of having rocket scientists get together and talk. It works. The ITU. Now, this is arguably the most active and influential international body you've never heard of. It's based in Geneva. It predates the United Nations. It's part of the United Nations. It actually has more members than United Nations. And it's there, and it looks after everything from cell phone signals all the way through to wireless telegraphy to satellite broadcasting. Its prime function in life is purely to prevent people broadcasting on top of each other, to prevent harmful interference. But they give us something called the radio regulations, which allows all of us to play in space. Whether you're doing a deep space probe, a space station, or a satellite broadcast, or a satellite internet. These are the rules of the road for space. And satellite communications is, as we've discussed, the bulk. Over $100 billion a year. That's 5 times NASA's budget, created through a bunch of international companies. As I said, Intelsat is the largest, SES is the next largest. They have the sort of top 5, Telesat, Eutelsat, then you get down to the JSATs, and you basically go out to the regional satellite systems and clusters. But there's about 53 or 54 satellite companies in the world, providing all sorts of incredible benefits to humanity. But one of the great benefits, as you're seeing up there, is a circle. You've seen this, we created this for you today. There's this kind of life cycle. You've seen one of the fishes in the sea. The little fish eats the big fish, eats the big fish, and the big, kind of goes around and around. Same in space. Lawyers, bankers, businessmen, insurance companies, satellite manufacturing, satellite launch, the actual use of the satellites, and the benefit that the satellites bring. Every single television station you've ever seen in your entire life bounced off a satellite. You're able to have national communication, international communication. We can respond to humanitarian crises within hours, whether it's an earthquake in Japan, a tsunami in Indonesia, or a famine in the northeastern Horn of Africa. Why? Because we can see pictures of them, we can hear people's voices, we can talk to people. Satellites and space have fundamentally changed human evolution. Now, what goes on up there? It's a great picture, isn't it, really? Shows you where all the satellites are in space. It's called the geostationary belt, discovered or first thought of by Sir Arthur C. Clarke. The idea that you put a really, really, really tall radio mast up in space, about 22,600 miles up, or about 36,000 kilometers up, and you could see enough of the Earth to broadcast to everybody. 3 satellites, roughly 3 satellites, you can cover about 98% of the world's population. And what you'll see there is these little clusters. Big cluster down there at the very bottom, to the left, slightly, United States. You come over to the right-hand side, look at the sort of 3 o'clock position, even makes like a number 3. That's Europe. Why? Well, you have 40-odd countries. Why build a TV station in every country when you can use one satellite to broadcast to them all? It's very easy. All the way through to Southeast Asia. Indonesia was actually the first country in the world to use commercial satellite communications. Why? Because they have an archipelago of over 1,000 islands. Satellite communications is a great way to reach a lot of people very quickly. And then you have that little gap down in the sort of 9 o'clock region, and that's the Pacific Ocean. Not too many people live in the Pacific Ocean. What does it look like? Wow, there you go. That's what space looks like from our perspective. So when Mr. Daniels was talking about space debris, you can see what we're talking about a little bit. Now, some of the distances are pretty huge, and we've shrunk the picture for you. But you can see that band of geostationary satellites, a bit like a Trivial Pursuit board or a Monopoly board, all the way around on the equator. And you can see everything down in low Earth orbit, which includes the shuttles and the stations. Mid-Earth orbit, GPS satellites and other things, Hubble Space Telescopes. It's a busy, busy place. But there's someone I wanted to give you an example of. I mean, I try to put myself in your position. I try to say, well, you know, what is the one thing that we've constantly heard from everybody that says, do not spend money on space? You know, don't spend money on space because starving people, poor people. There are people dying on the streets. Well, I want to talk to you about India. India formed the Indian Space Research Organization, ISRO. They formed their space agency in 1969. India had recently become an independent nation. India today, we know them as one of the BRIC countries. Brazil, Russia, India, China. One of the great growing powerhouses of global economies. But back in 1969, they were in real trouble. People were literally dying on the streets. People were dying of starvation, of disease. And yet that country took a step to form a space agency. So the very people that the anti-space crowd, the negative space people tell you, oh, there's poor, there's starving, everything. The very people who were poor, starving, and dying took it upon themselves to form a space agency. And you have to ask why. They realized that every dollar they spent on a space program was a dollar taken away from buying food for people who were literally dying on the street. They didn't do it for flags and footprints. They didn't do it for national pride. They did it because of national survival. And I would argue that ISRO is probably the best space agency in the world and has spawned more mimics, more copies of other agencies around the world. Look to ISRO in India for the lead they've taken. They've took the lead. They now develop their own satellites, their own launches, but they coined the phrase sustainable development. The idea being we have a growing population. How do we feed people? Crop management through satellites, forestry, looking at natural resources, the management of those resources, mapping. The first ordnance survey, let's say an ordnance survey map, it's like getting a AAA map of Houston. You imagine how fast Houston is growing. Well, imagine how fast Mumbai or Delhi was growing. The only way that the city planners could actually map out what to do in the cities with water and sewage and education was using pictures from satellites. It was just growing far too quickly. They pioneered the use of weather satellites to warn for disasters, not just for themselves, but for their neighboring countries in the region. Also telemedicine and teleeducation. The idea of broadcasting educational content, two ways sometimes with teachers. You do it over Skype the whole time. This is back in the 60s, this was revolutionary. The idea that you could have someone in rural India talking to a specialist in London or New York or Bombay as a doctor and operating and talking to people. And actually Intelsat helped pave the way for that. It's an incredible thing that space has done for humanity, but the Indians are really, really interesting. Now, there are quotes in there, but this is the guy, Dr. Vikram Sarabhai, who was the founder of the Indian Space Research Organization. And I'm just going to read this to you. You'll have the quote. Throw it at the other team if you want sometimes. There are some who question the relevance of space activities in a developing nation. To us, there is no ambiguity of purpose. We do not have the fantasy of competing with the economically advanced nations in the exploration of the moon or the planets or manned spaceflight. But we are convinced that if we are to play a meaningful role nationally and in the community of nations, we must be second to none in the application of advanced technologies to the real problems of man and society. What the Indians did, they took space and turned it inwards, and they used it as a tool. The former president of India was also the head of the Indian Space Agency. Every time the cabinet met on a weekly basis, every single cabinet minister from every department would have to justify his or her use of space and how that had fundamentally improved life in India, one of the poorest nations in the world. A lot of the technological boom that they are experiencing now comes from their space program, from the software engineering to the physical engineering of their satellites and launch vehicles. Another great quote, Dr. Kalam, former president of India, like I said, former head of ISRO. Many individuals with myopic vision questioned the relevance of space activities in a newly independent nation, which was finding it difficult to feed its population. Their vision was clear. If Indians were to play a meaningful role in the community of nations, they must be second to none in the application of advanced technologies to their real-life problems. They had no intention of using it as a means of displaying our might. So think about that. The very people who need it the most saw it the most and used it the most to the best effect. Now, with that, I'm going to quickly jump into why the rest of us in the world really kind of use the space thing. Aside from the commercial advantages, the military advantages, the societal advantages, why? And this is one of the things in life that drives me somewhat crazy, because for me, growing up on a small island, we were very aware of our resources. A small island, a small planet. We saw space, and we still see space on the Isle of Man as the ultimate way to save the human race. We see no argument in this. We see no ifs, ands, or buts. Now, this beautiful Earth that we live on, there's a picture actually taken yesterday by Colonel Ron Garan on the International Space Station of the moon, looking over the atmosphere. I mean, this absolutely gorgeous Earth, and every single day, and according to the United Nations, as of yesterday, 7 billion people wake up every morning, imagine it like a big crisp green apple. 7 billion wake up every morning, take a bite out of it and poop all over it. And it doesn't grow back. There's only one Earth. And that's something that space has helped us understand. But looking at the Earth, and just to quote an ancient Babylonian property developer, God made the world, but people keep on making people. And this is something that the United Nations has looked at. And this is like one of the great open secrets of the 21st century. President Reagan spoke at the United Nations about this. Every single Secretary General there's ever been has openly spoken about this. But the more openly it's discussed, the less ears hear it. It's this. It's the number. The frightening number. The reason why going to space is not a luxury. Why we have to go to space. That magic number, that horrible number, that number that keeps me awake at night, is 250,000. Every single 24 hours, 250,000 new human beings are born on this planet. By the end of this week, you guys are here for a week, it's about 1.5 million people. Those 1.5 million people have to be fed, clothed, housed. They have to have enough to eat, enough medicine. They need a car. They need a computer. Where are we going to get all this from? We thought 6 billion was the carrying capacity of the planet. We're at 7 billion now. We're heading to 9 billion by the time you guys probably come out of grad school. Look at that curve. We were down here, 7,000 BC, 6,000, we're doing okay, 1,000 BC, oh gosh, here we go, 1,000 AD, and boom, modern medicine hit us, and boom, agriculture hit us, and we started feeding ourselves and growing, lots of us. You're on a small island. Look at the example of Easter Island. And look what happened there. And that in itself is a horror story. And that's what's facing humanity if we don't go to space. Imagine that beautiful Earth and how much longer it's going to be that beautiful. And think back to the Cold War. 2 technologies came out of the Cold War that gave us very, very different viewpoints on life. Nuclear weapons could have completely, totally, and utterly, and still can destroy the human race. Actually, ABC weapons, atomic, bacterial, chemical. And spaceflight. Something that could actually save the human race, give us an option, give us an exit door out of the burning building. So we call this the digital decision, to go to space, yes or no. No is a definite 0. Our finite future, the population bottleneck. If we don't go to space, we will absolutely, without any doubt, die as a species. The Earth will keep going. Earth's been around for a couple of billion years. Dinosaurs, everything else, plants, wonderful. We'll be dead. There won't be any human beings left. Doesn't matter what kind of car you drive, doesn't matter, how big your bank balance, we'll be dead. Professor E.O. Wilson, Harvard, professor of ecology, quite a radical environmentalist, not a space fan at all. He said that even if we recycled 100% efficiency, everything, all the energy we use, everything we eat, drink, everything we create, with 100% efficiency, we only need 4 planet Earths if the rest of the world is to come up to the same standard of living that the United States has. Only 4. Now, it's all right, we're okay, because the World Wildlife Fund said, don't listen to that lunatic. Sorry, Professor, he's a very good guy. Don't listen to him, he doesn't know what he's talking about. We only need 3 planet Earths. Okay? So you're seeing the math here. We only have 1. We can't go out to Walmart and get another planet Earth. And look at the word rival. Its derivation is the same as the word river. We have been fighting each other for resources, for water, for everything, since there has been a human race. We're very good at it. Every single conflict in human history, from Laban's round with World War II to the Iraq wars at the moment, you could look at them any different way. They always boil down to resources. Have we breached our carrying capacity? I don't know. What's our future if we don't stay on the planet? Rationing, forced population controls, pollution, wars, totalitarian regimes. We have all that today, don't we? And actually things seem to be getting a little bit worse. Well, why are they getting worse? Because there's more and more people. And eventual extinction. Hope that doesn't, Too many babies, not enough resources. It's simple math, but it's a horrifying math. Also, that's just the stuff that we do to ourselves. What about natural, good old man, we talk about man-made, but what about good old natural stuff? Wouldn't that be great? Asteroids, supervolcanoes, bird flus, climate change. We really have a problem. And space is the solution to that problem. Space is the hardest thing human beings have ever done. It takes the hardest, most intelligent people that we have in every single discipline of human science and human endeavor. From the arts all the way through to science and engineering, everything we do. It's incredibly hard, but it's worth it. Now, a guy called Larry Niven is a fantastic sci-fi writer, but also, in his day job, he's a professor at the Jet Propulsion Laboratory, NASA's JPL. Now, what you're looking at there, if I can actually go back, see, there's that lovely picture of the Earth from Apollo 8, the one that our Vice President Gore, Senator Gore, said that, helped create the environmental movement in the world. When we look back and we first saw that the Earth was this beautiful jewel, wow, what are we doing to it? And one of the reasons we went to the moon was one of the reasons was for science, and we looked at the craters on the moon. And a lot of people thought they were volcanic. Big debate in the science community. But what we found that when we went to the moon was that, maybe a wee bit of them were volcanic, but the huge majority were impacts, asteroid impacts. The moon acts like a Secret Service agent for the Earth. It tries to catch all of those bullets aimed at us. All of those craters that we look at every night when we look at the moon, those are impacts. Now, there we were, and we just said, oh my gosh, wow, look at that, the moon, thank you, moon. And then we kind of turned around and we looked back to the Earth. And we went, oh no. We actually went back and looked at the Earth, and we saw these impact craters. And we realized that asteroids had been hitting the Earth with fairly decent regularity for a long time. In fact, they were probably kind of overdue for a couple of big ones coming our way. And it's one of my favorite quotes: the dinosaurs became extinct because they didn't have a space program. So, if we do go to space, less than the distance from Houston to Dallas, from Los Angeles to San Francisco, from New York to Washington, is a frontier of abundant natural resources. Imagine that, back to that apple, and 6.5 billion, 7 billion people taking a bite out of it. There's not just more apples in space. There's entire supermarkets full of apples in our solar system alone. There is more energy and resources than we know what to do with, could possibly ever know what to do with as a species. But there's those energy and resources that we can use to actually help improve life back down here on Earth. Solar energy, space-based solar power. The Trojans, the asteroids, near-Earth objects, going to the moon and Mars. My goodness, the moon, as we just recently learned in the last 12 months, we talk about helium-3, and we talk about water and exploration, and it's lovely. I'm really interested in all the uranium that's on the moon. The moon is covered in uranium. It's fantastic stuff. There's energy, there's resources, there's room to grow, social freedom and experimentation. Everything that the United States gave the world and continues to give the world today is there in space. It's that chance, that one chance to make it as a species. And there are gold, literally, there's gold in them there hills. And I'm just going to give you some silly math to finish up because I know you've had a hard day. And this is kind of fun math. So when you look at one of those asteroids, near-Earth objects, those are asteroids that come in near the Earth, near the moon and Mars, in between, we can get to them quite easily. You know, they're predominantly made of carbon, iron, nickel, steel, platinum, and rare metals. Sounds interesting, doesn't it? Well, there's one, and forgive my pronunciation, Tautatis, I can never pronounce that. My Latin instructor would probably beat me with a stick. But Tautatis is an Earth-crossing asteroid. It's about 1/3 the size of Manhattan. Eventually, it will hit the Earth. In about maybe 100, 180 years, depending on the math. Depending whose math you believe, it will hit. Probably an extinction event, but it won't matter to us because we'll be gone by then. It was first spotted, see, you've got to think about the future. It was first spotted in 1989. Radar tracks, it comes in every 4 years. The next time it comes in is December the 12th, 2012. It's a really boring asteroid if you talk to the scientists. And you should always talk to scientists. It's an S-class. There's lots of these things. Millions of these things between Jupiter and the Earth. I mean like millions and millions. It's an S-class chondritic iron asteroid. Mainly iron, okay? And some platinum group metals. Now, what does that mean? This one asteroid is 5 times 1 to the 11th tons, metric tons. 80% of it is iron ore. By the way, that's more iron ore than has been mined in the history of the human race. Now, if you could, this is the silly math, if you could put real figures on that, it wouldn't work that way because you'd flood the markets, but a ton of iron, as of June this year, was $170.88 per metric ton. So the price of that iron ore alone in the satellite, sorry, in the asteroid, is about $68 trillion. That's what, 4 times the national debt that everyone's freaking out about? So when I say there's resources and economy and energy up there, we don't have to fight each other over the uranium in the Congo. We don't have to strip mine the Amazon rainforest. 2 ounces of platinum is 20 square kilometers of Amazon rainforest. That platinum that we put in our catalytic converter to give us our green cars. 2% of Tautatis, 2%, is platinum. No one owns it. Now, there are laws, we have to obey them, and rules and regulations. But we don't have to fight anyone to the death. We don't have to prop up a third world dictatorship to get at it. We can actually have people here, like they do on the Mars rover, sitting in Houston in air conditioning, can go off and mine the solar system and bring immense riches back to the human race. Can fundamentally, again, change human history and human evolution and the chance for humanity to survive. Now, we're not talking about putting Bruce Willis on an asteroid and having him blow it up. But if we do see one of these things, we can actually maybe put a couple of robots and maybe some astronauts and miners there to mine it and change its course and actually take a threat and make it a real benefit to the human race. So, why do we go to space? For those in the international community, we look at this and go, it's to save the human race. That's it. If we don't do it, we ain't going back. It's the only reason we do this stuff. And a nice profit too. And I want to leave you very quickly with this quote from Cassius Clay, Muhammad Ali. And think about this too. Think about where these gentlemen came from with Space Services International, when everyone told them that it was impossible and it couldn't be done, and they did it. When everyone sat down with Goddard and Tchaikovsky and von Braun, and Disney, by the way. Go check out Walt Disney's role in the creation of spaceflight. It might surprise you. And they said, oh, it's impossible, it can never be done. There's people who sat down with H.G. Wells and Jules Verne and Arthur Conan Doyle and said, you guys are crazy for writing about this stuff. Always remember this. Impossible is just a big word thrown around by small men who find it easier to live in the world that they've been given than to explore the power they have to change it. Impossible is not a fact, it's an opinion. Impossible is not a declaration, it's a dare. Impossible is potential. Impossible is temporary. Impossible is nothing. And have a great week, and really well done for being a part of the Houston Urban Debate League.
So throughout the day, I've tried to draw an analogy for you between what the speaker said and those affirmative cases. And when y'all were listening to me last night talking about what I thought would be a great case was a multi-planet species, and we had to organize scarcity or create wealth, you just got the affirmative case outline given to you. So thank you, Chris, for leaving that with us, and I expect to hear that throughout the tournament. Now, I don't know whether we have we do. I'm getting a thumbs up. It was great of Dr. Franklin Chang Diaz to hang in there with us from Costa Rica, where he is the president of the Ad Astra Rocket Company. And we are so pleased to have him with us today. As I told you guys, there are a lot of people that went to a lot of effort to be with you today. Dr. Franklin Chang Diaz was an astronaut. He flew into space, and then he created and invented something called Vasimir, which is a revolutionary space transportation technology that he has been perfecting both at his offices here in Houston and from Costa Rica. We're so pleased to have you with us today, and I'll turn the podium over to you. Thank you again for joining us and for waiting with us while we have you here.
Thank you very much. I hope you can hear me. I hope this is a good connection. It's been kind of squirrely a little bit. Do you hear me okay? I guess I need to get a thumbs up or something. Okay, thank you. I got it. I was listening to Chris's presentation, and it struck me that both Chris and I, are talking to you as people from very tiny countries. He spoke about the Isle of Man, and I'm talking to you here from a little tiny country in Central America, which also has its sites in space, and we have an operation here which we believe is going to have a major impact on the future of space travel. And I had a few images to show you as I talk, so I'm going to see if I can share my screen here through the wonders of the internet, which let's see, share the screen. There it is. I hope you can see the screen. So if you see the image there, Charlie, can you give me a thumbs up? I see yeah, okay, thank you very much. So Chris kind of explained to you, the whole universe of possibilities that await for us in space, and this is sort of a cartoon that brings that home as well. You can see activities in low Earth orbit, which we know about now with the International Space Station. There, of course, there are activities in near Earth orbit, all those satellites that Chris talked about. And there's also traffic possibilities of interest on the moon. And that being the interest of many nations now, not just the United States and Russia, but also, Europe and China and Japan and India, South Korea, many other countries are getting interested and involved in space. And we keep on projecting further out in deep space. Now we're talking about going to asteroids, ultimately going to Mars and beyond. So, and also Chris brought up the size of the market that we see, to 260 or so billion dollars. So I'm not going to dwell on that because he covered it very well. So now, the space shuttle stopped flying, and everybody's all bent out of shape about that because, this is the end of the space program for the United States. And really, that is not so. I mean, in reality, what's going on is, of course, there was a little bit of a bad timing in the shutdown of the space shuttle, but that's what we have. And as a result, a gap, a hole has been created, which is a great opportunity for the private sector to move in and provide a service which really is no longer the purview of NASA. NASA was not created to truck astronauts and supply to the International Space Station, but in fact it was created to explore the unknown, to explore the frontier. And the frontier has gone way, way past the sort of low Earth orbit. And so now what we're seeing is a place for the private sector. And this is an example of what actually has happened. Two companies, SpaceX and Orbital Sciences, have landed sizable contracts from NASA, one for $1.6 billion over 5 years, and the other one for $1.8 billion over 5 years, to provide equipment and supplies to the International Space Station. Now, we're talking about sending humans as well. So the transportation to low Earth orbit really is going to be done by the private sector, letting NASA move out, move on, and be NASA the way it should be. So the key is we have some technologies that need to be developed. And this is an opportunity for all of you young people to move into a field that will mature over the lifetime of your careers. So this is an opportunity that I present to you. And the opportunities are in two areas. Power, electric power, just like on Earth, we need electricity, we need power. And the other one is propulsion, that is transportation, the means from point A to point B in space. Now, the way we travel in space is we do it with rockets. We have rockets that function pretty much the same way rockets were invented, thousands of years ago by the principle of action and reaction. And the key on a rocket is that you launch material out of the back of the rocket here, what we call the nozzle, or where the combustion chamber gets that material really hot, and the material escapes through one end, producing thrust and pushing the rocket in the opposite direction. And there are two kinds of rockets. There are chemical rockets, which are the ones here on the left, but there are also electric rockets here on the right. And the difference between the two is that the electric rocket, of course, uses electricity. And the electricity is used to heat a propellant, a fuel. There is no chemical reaction. The material gets really hot here simply by the action of electricity and goes out pretty much the same way as in this other one here. The big difference is that the fuel requirement for the electric rocket is very small compared to that of the chemical rocket. And therein lies the advantage, and therein lies the business opportunity. So if we could develop these rockets, we would be able to travel faster and much more efficiently in space than we do today. Today, If you remember, well, most of you don't, but if you can see images or movies of the Apollo moon rocket, that was a gigantic rocket, of which only a little tiny capsule actually made it to the moon or actually back to Earth. A very, very small amount of the rocket really is useful payload. And that's what we are trying to change. To get things really hot, we mean hot. We don't mean thousands of degrees like it is today in a conventional rocket. We mean millions of degrees. And that brings us to a technology which is based on plasma. And plasma is something that you will study, maybe you already have in school in your physics classes and so on. It is the stuff that the sun and the stars are made out of. It's extremely hot gas, so hot that the constituents, the inner pieces of this gas have been broken up into electrical charges, and so it becomes an electrical conductor. So the plasmas tend to be millions of degrees in temperature, and of course you would ask immediately, there is no known material that we can come up with that can hold these things. And that is true. There is no known material. Fortunately, because they are electrically charged, plasmas respond very well to the presence of electric and magnetic fields, and we can actually manufacture magnetic containers, magnetic bottles. And we are manufacturing one that specifically has a hole in one end, and that is what allows the stream of charged particles at those high temperatures to come out and produce rocket propulsion. So that is what we're trying to do in our facilities in Houston and here in our facilities in Costa Rica. This is a ranking listing of all of the rockets that there are. And you can see here all the chemical rockets up on the top, and as you get hotter and hotter exhausts, you get to the plasma regime right here on the bottom. And all rockets are characterized by a number, which we call the specific impulse. That tells you how good that rocket is. The bigger the number, the better the rocket. So the rockets of today that we fly, the space shuttle, for example, the boosters that are launched, that help launch the shuttle, are all very low performance. You need to move into this range of performance where the specific impulse is not hundreds of figures, but tens of thousands of figures, you see? And that is where we are moving to. So here we are building a device which, in essence, is a sleeve of magnetism, a magnetic sleeve created by a superconducting magnet. There it is. It's like a string of rubber bands, you can imagine. And we use antennas. We don't heat the plasma by direct contact. We heat it pretty much the same way you heat your coffee in your microwave oven. We use electromagnetic waves. And we inject gas at one end, and this gas becomes a plasma. It becomes a cold plasma, which in our jargon, cold plasma is something on the order of about 40 to 50,000 degrees. We let that plasma move into another section of the rocket, and that is where we pump a lot of energy into it, and it becomes very hot. Energized plasma starts out at about 1 million, accelerates to about 2 million degrees, and then that energy stored in the plasma is released in the form of rocket propulsion. And that jet of plasma is what makes the Vascular engine move very efficiently and deliver cargo to deep space very fast. So that is the material or the technology that we are developing. Give you a sense for where these things are, ranked. rockets can relate to everyday life. NASA has been working with these plasma rockets for many, many years, and all we have done so far in the early development are these very tiny electric rockets that you see right here that compare in capability to an electric scooter or to a golf cart. The engine that we are now developing in the laboratory in Houston is 200 kilowatts. It compares to about nice, sporty Tesla Motors Roadster, about 200 kilowatts electric vehicle. We now want to move also to very powerful rockets at thousands of kilowatts or megawatts, which compare to tugboats. And the reason we want to do that is precisely because we want to build a space tug that can go and pick up all those satellites that are dead that Chris spoke about in his talk. And then ultimately we want to build rockets that are very powerful to power human missions to Mars. Now here we're talking about rockets that operate at hundreds of megawatts. Now these things, of course, don't exist, and neither do the power sources. The power sources will be nuclear reactors, which do not exist either. So these are the opportunities for you to move into a field which is completely virgin, completely new, and very exciting, enabling humans to really spread out throughout the entire solar system. The engine cluster that would drive humans to Mars would compare to the power of a 747 aircraft on takeoff. And that is a significant amount of power, but it's not an unreasonable amount of power given how far we have to go. I mean, Mars is a long ways away. So let's see what this thing got frozen. So our facilities are located in Houston, just about 2 miles or so from NASA, from the Johnson Space Center. Here you see our building up on the top, and you, as high school students, some of you, I think, may have already come to visit us, but we have an open door policy, and we welcome the visits from young people who would like to seek a career or move into this field. We have one of the largest test facilities in the country, one of the largest vacuum chambers where these rockets are tested. And our team is a very young team, you can see right here. We have facilities in Costa Rica as well, where I am talking to you from, a very small facility, about 10% of the total company. And we have a young team as well there. The average age in our company is about in the middle 20s or so. So a very, very young group of people. You see the inauguration of our facility was in Costa Rica, was done on the 15th of July of 2006. So it's a fairly new facility. You can see here President Oscar Arias, Nobel laureate. He won the Nobel Peace Prize, cutting the ribbon, along with Professor Sam Ting, another Nobel laureate, physics from MIT, and Professor Rolf Zagdeyev, the former director of the Soviet Space Science Institute in the times of the Soviet Union. So very interesting how space has become totally globalized, and we do research every which way, everywhere along the surface of the Earth, thanks to communications and the internet that has brought us together. We're located in the northwest of the country, beautiful area right here, very close to the Pacific Ocean. So it's a great place to also just be. This is the facility in Houston, and this is the rocket, the VX200, Vasmer Experiment at 200 kilowatts. It is presently the most powerful plasma engine in operation in the world today. It is firing in the lab, and like I said, you're certainly welcome to come and see it and visit. You see here various aspects of the engine during test. This is an image of the firing. These firings last in our chamber on the order of about 30 seconds, over which we measure a great deal of parameters that we need to determine the performance of the rocket. You see some of the data that we take. I'm not going to bore you with that, but I'm telling you one thing is that we are moving from the technology of the laboratory to deployment of the engine in space. And that is our next step. So here is where we are right now in the development of the technology, VX200. And we want to go here in the year 2014, 2015 timeframe. The way we're going to do that is we're going to put this thing on the International Space Station. It will be placed in an assembly test platform, which we call Aurora. And it would be not just a carrier for the engine, but it will also be a carrier for multiple other experiments that need to be done, and continue to use the space station as a test facility for technology development. You can see here it will be placed in the middle of the station, right about here, because we, of course, when we fire this rocket, we don't want to spin up the space station. We want to provide the thrust in the right place. It will not be sent, obviously, by the space shuttle. It will have to be driven up there by a conventional commercial carrier. And right now, we're talking to both of the companies, SpaceX and Orbital Sciences. It'll be deployed in this form. And it will be, you can see here some scenes of the capture of the package as it arrives on the space station. It will be captured by the robotic arm from the station. It will then be delivered to an intermediate point while the astronauts then release this carrier vehicle, which is called Cygnus. This will be released, and this will be thrown away. Will burn in the atmosphere, leaving the rest of the package in an intermediate position, so the arm can come and repositions itself in another location and picks up the package, and it puts it back, it puts it right on its final resting place right here, where a couple of astronauts will be ready to do the proper matings of mechanicals and electrical connections and so on to get it ready to fire. This is what it will look like when it's completely ready for firing. You can see here the engine will have two barrels, two nozzles, so the plasma jet will come out of two ports. And these are radiators that get rid of excess heat that the engine will produce. So this is the test facility that we intend to mount. Now, what kind of business do we envision with this sort of thing? Well, here they are. We expect that these engines will be used to keep the space station in orbit. I mean, space station and other orbiting stations suffer from drag. This drag is caused by the atmosphere. And over a year, we're talking several thousands of pounds, or actually kilograms, of rocket fuel have to be sent up into space to be able to keep that station in orbit. And we're intending to reduce that cost significantly. So we will do the servicing, repositioning, and the disposal that Chris talked about of the orbiting satellites. All of those tens of thousands of satellites, and many of them dead, will be removed from their orbits and placed into graveyard orbits. We also we will use it for robotic exploration missions deep into space in preparation for very powerful engines in the future, which will deliver primary propulsion for human missions. Here you see a concept for the orbiting 10 polar satellites. This graph right here shows how we, with a single mission, can go and pick up 10 of these satellites, and we will drop them into the atmosphere to burn up in the atmosphere. These are low-flying orbital assets in polar orbit, with very strong revenue streams of the order of 100 to 150 million per year. This is another potential area of business, reboosting space stations, as I told you before, with potential revenues of the order of also between 100 and 150. We also vision delivery of cargo to Mars. Mars is an interesting place that will be increasingly visited by all kinds of interests, space agencies, countries, and so on. And we have calculated that with a Vasimer engine using solar power, solar panels, we can nearly triple the payload that we can deliver to Mars given a single launch. So that is an interesting margin for us to look to in a business engagement. So we're looking at this very, very closely. This is the last one that I wanted to show you, which has to do with delivering cargo to deep space, points in deep space. This one delivers a payload to the vicinity of Saturn, Jupiter. And it does that by launching the spacecraft from the Earth, from Earth orbit, moving on a trajectory that brings it near the orbits of Venus and Mercury. And in this green portion of the trajectory, the great illumination from the sun, because we're closer to the sun, gives the engine a tremendous amount of power, which allows it to accelerate. And at this point, we release the payload, and the payload goes on its way to Jupiter on its own. But the actual tugboat, the actual carrier, actually returns to Earth and positions itself for another run. So in many ways, we are sort of creating a kind of a DHL sort of concept for delivering cargo to deep points in deep space for, of course, for a fee. So another business scenario. And there are many more. I just wanted to tickle your imagination. Some people are talking already to go past the space station and start considering to establish habitats, human habitats, in places such as the Lagrange libration points near the moon and the Earth, in preparation or as staging points for human exploration deeper into space. And this may happen in the next 10, 20 years, maybe less. I don't know. This all depends. But these things are being now looked at. And of course, we see the development of a very large, capable ship, which in this case is shown here. This is an artist's rendition of such a ship. Now, this ship is very powerful. It has 4 nuclear reactors. These reactors do not exist, are reactors that need to be developed. They produce electricity, and the electricity is used to drive the engine package, which is here in the back. The habitat for the crew would be in the cylindrical section, which will be surrounded by these tanks, which will contain liquid hydrogen. Liquid hydrogen will be the propellant from which we make the plasma, but it will be stored in these tanks in liquid form. And as such, it will form a shield against the radiation, which is one of the most serious impediments for human exploration. So this is the conceptual idea. As you can see here, a little bit of a closer view of the vehicle and the back. These areas here that look like the petals of a flower are simple, not more than radiators, because these nuclear reactors are not 100% efficient. They have to release or get rid of additional or of excess heat that they produce when they make the electricity. So this is the concept. You see here another view. This dish-like structure here is a gamma shield to shield the vehicle from gamma rays produced by the fission reaction going on in the reactor core. So these are the kinds of images of the future that I wanted to leave with you. And in reality, The only limitation here is our imagination. I mean, these kinds of things are going to happen, and it's just a matter of when and who are the people who are going to make this possible are most likely you. So I'll leave you with that thought. Thank you very much.
Thank you very much, Franklin. Pretty good, huh? Shall we take one question for Franklin? Does anybody really want to stretch their brain a little bit and ask about what about that going to Jupiter thing, or any questions that we can relay, although it sounds like we don't have him anymore. Franklin? Okay.
I was going to ask if it was stated earlier that space was the way that we were going to save the human race. I don't know how to work. But space was the way that we were going to save the human race. How would we do that? Like, how are we going to get to there? Are we going to do it with national corporations? Are we going to do it with private companies? Or are we going to do it with something else? Like, how would we get there? And would it be an international effort, I suppose?
Franklin, did you hear that question?
Yeah, I think so. I think I copied how we're going to do this. Is it going to be, like the old-fashioned way that, one single country? No, it's going to be it's definitely going to be an international endeavor. I think the old paradigm of, one country competing with another in space it's really old hat. I mean, we really have moved away from that. And it is entirely a global endeavor. It's an international effort, and it's going to have a very strong private sector ingredient. It's not going to be exclusively government. It's going to be a mixture of private and public.
Chris, you want to comment? And then we have another question.
Thank you, Johnny. And good question. Actually, I really can't add to anything Franklin said. It will be, just as he said, it'll be international. It'll be governments, it will be corporations, it'll be entrepreneurs. It's going to take everything that we have to pull this off. And now you'll probably see everything under the sun and probably some new ideas coming out on how to do this too, in terms of international cooperation.
And pay attention to the Isle of Man. Do we have another question?
Yes.
Tell us who you are and where you're
Timothy
from.
Messon from Carnegie Vanguard. And so you're talking about the idea of a multi-planet species. But do you really think it's possible for humanity to get to some possible place for us to live in the time before we destroy the planet that we live on?
Sure.
I mean, it's possible, you think?
We'll start with Chris.
Yes, I'll just jump in, Franklin, if I can, just quickly. Absolutely. One of the people to go back and look at is the work of a gentleman called Gerard K. O'Neill from Princeton University. And he looked at actually putting habitats in space, as well as colonies on the moon, Mars, etc. It's everything that we can do there is absolutely technically achievable today. Well, the old quote, we have the technology. What we're lacking are the business plans and the sort of political will to do that. I think we absolutely can. And, 42 years ago, we made a first footstep there. And I think if you look back in time, I think it was about 40-odd years in between when Columbus first hit the New World as to when the first major colonies stepped up too. There seems to be this 40 or 50-year lag. Fingers crossed we can do it. Sincerely, I have a son, and I hope he will have many grandsons and great-grandsons. And I hope you all do too, in the nicest possible way.
Franklin?
Yeah, no, I agree. I totally agree. I mean, we have to open our minds. The capabilities of humans are extraordinary, and we don't want to live constrained by living inside a box. We need to completely open our minds and think completely out of the box in this.
Okay, we'll take one more.
You said that we should be a multi-planet species, but on the road to that, the question is who goes?
No, actually, very good question. And you'll find a lot of research out there. As Charlie mentioned earlier, too, I'd go look at the International Space University. Lousy name for a school, but a great place. They've actually looked at this a lot as to who gets to go, who should go. And I think if you answer this, every time you answer this question, depending what year you answer it, you get a different answer. If you answer this question back in the 1960s, it would be 7 white guys. If you answer this question in the 1980s, it would be a whole bunch of white guys and a bunch of white girls. If you answer this question all the way through to today, you'll find that space has become so international, and even the space tourists are from around the world. So you have men and women of every color, creed, race, and religion up there. And I think that's the way to go, because you can't, and it's an odd thing. Working in the space industry, and I know this is going to sound such a pathetic thing to say, but we don't tend to see sex or color anymore. And it's a strange thing, I know that. And we live in our own little ivory tower, I use the word ivory, but we live in our own little ivory tower, and we work in this incredible industry with incredible people. And we're just around people all the time who, on average, have a master's degree or a couple of PhDs. And you see the person. And often, you'll be out in public somewhere and someone goes, oh my gosh, you guys are, you're from around the world. And we're like, yeah, isn't everybody else? And I think, and so that maybe if you look at that part of space, and maybe hopefully we're pushing the envelope there too. It's, everybody all the time has skills, and that's what we need. Good question.
Franklin?
Well, I agree. Everybody should get to go. If space were limited, if space were limited to a bunch of astronauts, just like it is today, and it was forever limited to a bunch of, selected few, I think we'd be wasting our time. It has to be open to everybody. Otherwise, doesn't make any sense.
Thank you. Thank you, Chris. Franklin, thank you very much for joining us today from Costa Rica. And good luck. And I bet these kids will take you up on your offer to host them in Houston. And we'll be calling you about that. Bye-bye. Okay, well, a little bit behind schedule, but that brings us to the conclusion of the Hubble Space Talk today. So I want you all to hold your applause for just a moment, but please thank all of our speakers, thank our hosts at the Baker Institute, and give yourself a round of applause. This has really been a good day for everybody. And now I'm going to turn you over to Elizabeth, it looks like. We have a few parting gifts for Chris and Jim and folks that haven't picked theirs up yet, but back to Ms.
Yes, let me just close this out. Let me ask for a special round of applause for Charles Chafer, because, when he started talking to me, I have to admit, I sort of think in the 20th century, not quite to the 21st, and certainly not to the intergalactical expanse that we're talking about. And I'm here, I don't know how we're going to do this, but we did. And I really have to thank our hosts, Baker, and I have to underscore 2 words for you, just 2. Team, as Charlie mentioned. You can't even see the number of people who are working on this right now. This is like the Wizard of Oz. They're behind that door and they're making all of this happen. They're out front making it happen. There's a team and diversity and inclusion. It's the work I do. It's the work you live. It's the work that I actually use space and NASA as examples of diversity and inclusion, and bringing people of difference together with different backgrounds and perspectives, because you can't get anywhere in the future with the same thinking. And so I think we have witnessed today what I believe James A. Baker III would be very proud of. This thinking outside the box, thinking, forward thinking on policy. And you're a part of it. You're going to remember today. And you were a part of it. So I want to say thank you. I think we are completed with our program. This has just been terrific. Thank you.